Pluto and Charon have long captured the imagination of astronomers and the public alike. For most of the 20th century, Pluto held the prestigious title of being the 9th planet in our solar system, but all of that changed in 2006. It was then that the International Astronomical Union, IAU, made a controversial decision to reclassify Pluto as a dwarf planet. This decision was based on a set of specific criteria, which Pluto, by its very nature, failed to meet. But could this reclassification be wrong? Could Pluto still be a planet, and could its moon, Charon, actually be more than just a moon? Could these two celestial bodies, bound together in a cosmic dance, represent something entirely different than we once thought? The debate over Pluto's planetary status is more than just a matter of semantics. It touches on the very definition of what a planet is and how we classify the various objects that populate our solar system. At the heart of the debate is Pluto's relationship with Charon, its largest moon. When Charon was discovered in 1978, it revealed a peculiar aspect of Pluto's nature. While most moons orbit their parent planet, Charon orbits around a common center of gravity with Pluto, a center of gravity that lies outside of Pluto itself. This is a highly unusual arrangement and one that raises questions about the traditional definition of planets and moons. Normally, a moon is a natural satellite that orbits a planet, and the planet's gravity dominates the system. But with Pluto and Charon, the two bodies are so similar in mass and size that they both exert significant gravitational pull on each other. The result is a binary system, with both Pluto and Charon orbiting around a shared center of mass. This is not how most planetary systems work, and it has led some scientists to wonder if Pluto and Charon should actually be considered a double planet, rather than a planet and its moon. This idea challenges the very foundation of our understanding of the solar system and raises the possibility that Pluto was wrongly demoted in 2006. When Pluto was first discovered in 1930 by astronomer Clyde Tombaugh, it was hailed as the 9th planet of our solar system. At the time, Pluto was a tiny, mysterious world, located far beyond the orbit of Neptune. It was an exciting find, one that seemed to confirm the predictions of astronomers who had theorized that a planet might exist beyond Neptune. Pluto's discovery filled a gap in the solar system, and for decades, it held a special place in the hearts of many. But Pluto's status as a planet began to come under scrutiny as astronomers made more discoveries in the outer reaches of the solar system. In the late 20th and early 21st centuries, astronomers discovered more and more objects beyond Pluto, in a region known as the Kuiper Belt. This region, which lies beyond Neptune's orbit, is filled with icy bodies, dwarf planets, and other small celestial objects. Among these objects are Eris, Haumea, Makemake, and many others, each of which is similar in size and composition to Pluto. This flood of discoveries prompted scientists to question whether Pluto should still be considered a planet. After all, if Pluto was to be classified as a planet, then why not include all the other similar objects in the Kuiper Belt? In 2006, the IAU decided to address this issue by redefining what it means to be a planet. According to the new definition, a planet must meet 3 criteria: it must orbit the Sun, it must be nearly round in shape, and it must have cleared its orbit of other objects. While Pluto met the first 2 criteria, it failed the third. Pluto shares its orbit with other objects in the Kuiper Belt, and because of this, it was reclassified as a dwarf planet. This decision was met with shock and disappointment by many, and the controversy over Pluto's status has continued ever since. However, new data from NASA's New Horizons mission has shed light on the true nature of Pluto and its relationship with Charon. In 2015, New Horizons flew past Pluto, providing the first detailed images of the dwarf planet and its moons. The images revealed a world of surprising complexity, with vast plains, towering mountains, and even evidence of glaciers. Pluto was not the barren, lifeless world that many had imagined, it was a dynamic, geologically active body. Charon, too, was shown to be a world of incredible variety, with vast canyons, large craters, and evidence of past tectonic activity. The data from New Horizons also revealed that Pluto and Charon share many geological features, suggesting a deeper connection between the two bodies than previously thought. the most striking feature of the Pluto Charon system is the way the two bodies interact. As mentioned earlier, rather than one body simply orbiting the other, Pluto and Charon both orbit a shared center of mass. This means that the two bodies are in a constant state of mutual gravitational influence, with neither one dominating the other. This dynamic is reminiscent of a binary star system, where two stars orbit each other in a similar way. But instead of two stars, we have a planet and its moon. This unique relationship has led some scientists to propose that Pluto and Charon are actually a binary planet system, rather than a planet and its moon. If this hypothesis is correct, it would mean that Pluto was unfairly demoted in 2006. Rather than being classified as a dwarf planet, Pluto might actually be a legitimate planet, and Charon might be considered a companion planet rather than a satellite. This reclassification would have far-reaching implications for how we define and categorize celestial bodies in our solar system. It would challenge the traditional distinction between planets and moons and could lead to a reassessment of other binary systems in the solar system. For example, astronomers are now taking a closer look at other objects in the Kuiper belt, such as Eris and its moon Dysnomia. Like Pluto and Charon, Eris and Dysnomia are in a binary system, with both bodies orbiting a common center of mass. Could this be another case of a binary planet system? What about Haumea and its moons? Could these objects also be part of a new class of binary planets? These questions are prompting astronomers to rethink their understanding of the solar system and the ways in which celestial bodies interact. The implications of this new way of thinking about Pluto and Charon extend beyond just these two objects. If Pluto and Charon are a binary planet system, then it could mean that there are many more such systems in the solar system, systems that have been misclassified as planets and moons. In fact, some researchers are even suggesting that the Earth's moon might not be a moon at all, but rather a small planet that was captured by Earth's gravity long ago. This idea is based on the fact that the Earth and its moon are similar in size and composition, and the dynamics of their relationship are more complex than the typical planet-moon pairing. If this hypothesis is true, it could mean that the distinction between planets and moons is not as clear-cut as we once thought. The traditional view is that a planet is a body that orbits the Sun, while a moon is a body that orbits a planet. But if the Earth's moon is actually a small planet, then this definition may need to be revised. And if Pluto and Charon are a binary planet system, then the whole concept of planetary classification could be called into question. The idea of Pluto and Charon as a binary planet system also raises interesting questions about the formation of these bodies. How did Pluto and Charon come to be in such a unique arrangement? Could their relationship be the result of a cosmic accident, or is it a natural outcome of the way planetary systems form? Some scientists believe that Pluto and Charon were once part of a larger object that broke apart, with the two bodies remaining in a gravitationally bound relationship. Others suggest that the two bodies may have formed together, from the same material in the early solar system. Whatever the case may be, the unique dynamics of the Pluto-Charon system provide valuable insights into the processes that govern the formation of celestial bodies. In addition to challenging our understanding of Pluto and Charon, the new discoveries about these bodies are also raising important questions about the nature of the solar system as a whole. The solar system is a dynamic and ever-changing place, and our understanding of it is constantly evolving. The study of Pluto and Charon is just one example of how new data can change our understanding of the universe. As technology continues to improve and we gain access to more detailed observations, it's likely that we'll discover even more surprises that challenge our current models of the solar system. One thing is clear: Pluto's story is far from over. While many have accepted the idea that Pluto is a dwarf planet, the new findings about its relationship with Charon suggest that we may have been too quick to dismiss Pluto as insignificant. Perhaps Pluto and Charon represent something much larger and more complex than we've previously thought, something that could force us to rethink the very definitions of planets and moons. The debate over Pluto's status is not just a matter of academic interest, it's a reflection of the constantly evolving nature of science and the quest for understanding. And as we continue to explore the far reaches of our solar system, we may find that the story of Pluto and Charon is just the beginning of a much bigger cosmic revolution. In the end, whether or not Pluto is reclassified as a planet is not the most important aspect of this debate. What matters is the way in which this discussion forces us to rethink our assumptions about the universe. The story of Pluto and Charon is a reminder that science is a dynamic, ever-evolving field, and that our understanding of the cosmos is always subject to change. With each new discovery, we come closer to unraveling the mysteries of the solar system and the universe beyond. And who knows? Maybe Pluto and Charon will be the key to unlocking even bigger secrets that lie waiting to be discovered.